Good morning to one and all. Previous classes we have discussed about measures of dispersion of the basic introduction of measures of dispersion. So what is mean by measures of dispersion and what are the types of measures of dispersion? And within that we have discussed about that relative dispersion and absolute dispersion. So today we will discuss about that range, quartile, and mean deviation. So within the observed dispersion, we have that range and quartile deviation and mean deviation along with the standard deviation variance. Today we will discuss only three topics, that is a range, quartile deviation, mean deviation. Yeah, yeah. As we discussed, these are the observed dispersion and these are the relative dispersions. See, this observed dispersion is the range, quartile deviation, mean deviation. So, if the time permits, also we will discuss about the relative dispersions of relative coefficient of range or coefficient of range or coefficient of quartile deviation, coefficient of mean deviation. So, probably we will discuss also these three also and along with the observed dispersions. Yeah, today we will discuss about range and quartile deviation, mean deviation, along with the coefficient of range, coefficient of quartile deviation, coefficient of mean deviation. Yeah, first we need to understand what is mean by range. What is mean by range? So here range is nothing but the range is the difference between smallest and largest value of a set of numbers or data. Or simple, you can take the example also. See, simple range is nothing but the difference between the highest value and smallest value, or highest value or lowest value. The range is nothing but the difference between highest value and lowest value, or largest value or smallest value of set of data or set of numbers in a particular data series. The formula of range is nothing but R is equal L minus S. L is nothing but largest value, S is nothing but smallest value. For example, generally we can use the term range. For example, when you want to do some shopping, so simple, if you went to the particular shop, the shopkeeper will ask that, so what is your range to purchase a particular commodity or particular dress, for example. So simple, you can say that if you want to purchase the 300 to 500 dress, for example. So you may say that your range is 300 to 500. So in the between the range, that is the highest value and lowest value, in that only you are going to show the particular commodities which are under the range of 300 to 500. So in that term we can use the range, and how we can calculate the range also we can see. For example, another example also I will use later. See, for the example, find out the range by following the data set. Following the data set, for example, if you take into account, I have taken a 4 number of students in a particular class. So they scored, the first person scored 88, and another person scored 65, another person scored 39, and another person scored 45. So within among these 4 marks, how we can calculate the range? The range formula is nothing but R is equal to L minus S, or H minus L. So I is nothing but highest value, L is nothing but lowest value. So both are same, but see the highest sorry, your lowest, yeah, sorry, your largest value L for your lowest value. Okay. So as per this formula L minus S, I am going, then R is equal to L. L is nothing but largest value. Largest value is nothing but how much within the 4 or among the 4. 88 is the largest value, and lowest value is nothing but, or smallest value is nothing but 39. 88 minus 39, how much you are going to get? 49. That is the range is 49. But when we are talking about a range, we can simply say that 39 to 88. 39 to 88. That is our range. So generally, in statistically, the range is 49. The thing, but we need to calculate the difference between the highest value and lowest value. So another example, if you take into account, for example, if I conduct an internal exam, so some people will get the marks out of 20, for example. See here, one person got 5 marks, another person 10, another person 15, 20, 7, 9, like this. Okay. So I'm going to find out the range. Who got highest marks, who got lowest marks. And at the same time, what is the range of the internal marks? See here, that is I for here highest value, L for the lowest value here. Range is nothing but. So what is the highest value in the internal exam? 20. Someone has got 20 marks. What is the lowest one? Lowest marks. So when you observe 5 marks is the lowest value. So h minus L, 20 minus 5 is equal to 15. So the range of internal marks is 15. Nothing but there is a huge gap between that persons. Nothing but the lowest value, lowest marks and highest marks. Okay. So that is the case. We can find out the range. For example, if you want to take into account another example also, see. So I want to know that what is a who has a more age, who has a young age, nothing but who is the old age person in the class, who is young age person in the class. So also I will take, for example, I will collect information about the ages of the students. Then I will want to know the who is the old age and who is the young age. So what is the range between the highest value and lowest value of the age? Or else, if you want to take into account, if I want to collect information about that incomes of a particular street vendors, for example, if you take into account, so if you want to do a research on your street vendors income, so meanwhile when you are asking a question to the street vendors, so what is your monthly income, for example, so somebody will say that 1,000 rupees, somebody will say that 10,000, somebody will say that 500, somebody will say that 12,000 or 9,000 or 8,000, like that. So after collecting the data about the income of the street vendors, so you will find out what is the highest income, nothing but highest income and lowest income. So meanwhile, highest income minus lowest income, you are going to get range. So if the range is high, we can see that there is a huge dispersion. There is a huge variation between the income of the street vendors. Income of the street vendors. We can give the conclusion like that. Is it clear now, students? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Thank you. So next we will go for another example, which is very useful, which is very easy. Another example, if you take into account the range, find out the range by following the data set. For example, when you are purchasing mobiles, so the prices are very different. For example, if you take into account, so I have taken only 4 mobile prices, for example. So I'm assuming that the price of the mobile is 18,000. Another mobile, Redmi mobile is price is 16,500. Another is 14,500, and another is 15,500. So, for example, if you take, there are 4 Redmi mobiles are available in the particular shop. When you are enter into the shop, the salesman will ask that what is your range. You are entering the particular Redmi mobile shop only, for example. So they will ask that, the salesman will ask that. So can you say that what is your range, sir? Like that they will ask. So if you say that my range is 14,000 to 18,000. So they will show that whatever the mobiles are available from 14,000 to 18,000, they will show. Then, so what the range is, the 14,000 to 18,000. That is the 4,000. But in our data, we have the highest value is 18,000 here, and smallest value, that is the 14,500. The highest value is the largest value minus smallest value. Largest value is 18,000, smallest value is 14,500. The range is 3,500 rupees. Nothing but there is a difference between the two mobile prices. That is the 3,500. Okay. So if the range is very high, it means that there is a huge variations or huge variability, huge dispersion among the mobile prices. For example, if you take into account Samsung prices, Samsung mobile prices, if you want to purchase a 1,000 rupees mobile, maybe it may be available in the market. So if you want to purchase by paying the 30,000, 40,000, so it may be available. It means that there is a huge variation between the mobile prices. Okay. Have you got the point, or still I want to explain anything? I hope you understood.
Yes, sir.
Yeah. Then we have in the relative dispersion, relative dispersion, we have a coefficient of range also. So what is mean by coefficient of range? What is the formula of coefficient range? See, when somebody will ask the question that find out the coefficient of range by following the data set. Simple. The formula is coefficient of range is nothing but L minus S divided by L plus S. Simple. L minus S and L plus S. Simple here. Coefficient of range. L minus S divided by L plus S. L largest value minus smallest value divided by largest value plus smallest value. For example, they will find out the coefficient of range by following the data set. So these are the data set. For example, 88 marks, 65, 39, 45. So earlier we have taken this marks also. See, this CR is the coefficient of range. C dot R coefficient of range is equal 88 minus 39 divided by 88 plus 39. Then CR is equal to 88 minus 39. How much? 49. Divided by 88 plus 39. How much? 127. When you cancel that 49 by 127, you are going to get the 0.8385. Sorry, coefficient of range is equal 0.385. Nothing but 38.5% of the variation or dispersion in the marks. Is it clear? There is we can express the coefficient of range in terms of percentage also. Here we can conclude that. So among these 4 marks, so there is a 38.5% of the variation in the external marks. Is it clear now?
Yes, sir.
So another example I am going to give the just as we discussed about that street vendors income. Okay. For example, if you take into account when I told you that, for example, if the one person street vendor's income is per month is 5,000, so another was 6,000, 7,000, 8,000, and 12,000 is the maximum. For example, when you calculate it, the 5,000 and 12,000 minimum is 5,000 and maximum is 12,000. So what is the coefficient of range? 12,000 minus 5,000. How much? 7,000. The range is 7,000. But if you want to say that in percentage, how we can say? Simple. 12,000 minus 5,000 divided by how much? 12,000 plus 5,000. 19,000. How much will get? 36.8. This is nothing but we can say that there is a 36.8% of the variation in the street vendors income. Street vendors income. Is it clear now?
Yes, sir.
Yeah, whatever we collected information in the sample area. Yes. Yeah. If it is clear, and I will go for the another third one. Yeah. Then third one, the quartile deviation. So quartile deviation. See, for example, what is meant by quarter? For example, see when the so drinkers only they can know that what is a quarter. Nothing but it's a 1/4. 1/4. Okay. So for example, if you take into account, for example, if you want to know that if you want to fill water in a particular bottle, so how much it fill? For example, it will be 1/4, 1.5, 3/4, and full. You can say like that. See, so when the sum, if the data is in the terms of centimeters, if the data in the marks also, we can calculate the quartile deviation, and in terms of quantity, in the particular weight also, we can calculate the quartile deviation. So here the quartile deviation, that's the QD, is a type of range. Nothing but the quartile deviation is nothing but is a type of range which are based on the quartiles, For example, so when we have calculated that income of the street vendors and the marks of the students, so it is based on the full data. But yeah, the deviation we can measure on the base of quartile based. How much the different? How much the deviation? How much the deviation within the quartile? అంటే ఇక్కడ ఏంటంటే ఒక్కొక్క భాగంలో మనము ఎంత deviation అని ఇక we can learn. So it is half of the distance along the x-axis between Q1 and Q3. Q1 is nothing but quarter of 1 and quarter of 3rd. So for example, if you take into account when you take this 10 centimeters of the any thing, for example, if you take any 10 centimeters of cloth, so what is the quarter 1 here? 2.5 centimeters is the 1/4. The what is the half of 5 centimeters? What is the quarter 3? 7.5 centimeters. Okay, like that, quarter 1, quarter 2, quarter 3, quarter 4, nothing but, so whatever the, if you want to know the quartile, so simple, we can divide into that four equal parts, nothing but the 10 centimeters can divide by the 4. How much we will get? 2.5, 2.5, 2.5. Okay, like this, we can calculate the quartile deviation. And quartile deviation, yeah, quartile deviation formula is, see, this is the formula of quartile deviation, q3 minus q1 divided by 2. That is a formula. So in order to calculate the coefficient of quartile deviation is q3 minus q1 divided by q3 plus q1. Here there is no by 2. See, simple, within the range also we discussed that coefficient of range are L minus S by L plus S. Here quartile deviation q3 minus q1 divided by 2, but here coefficient deviation q3 minus q1 divided by q3 minus plus q1, not by 2. Okay, here not by 2, here not by 2. Simple, you can remember. Then how we can calculate the quartile deviation also, we can come to know that. See, example, the find out the quartile deviation and CQD nothing but coefficient of quartile deviation. C dot QD are nothing but coefficient of quartile deviation. So here we can find out that QD and coefficient of quartile deviation for the following data set. So the data is given 12, 7, 15, 10, 19, 17, 25. So what we have to do by following this, by using this data, there is the first step. We need to arrange the data in the ascending order. Ascending order, nothing but small to big. Ascending order, small to big, small to big. Then second step, to find out the Q1 and Q3 and Q1, or Q1 and Q3. Okay. So next step, we need to find out what is the Q1 and what is the Q2. Then third step is select Q3 and Q1 in the particular data set. See, simple here, say the first step we have followed that arrange the chronological order, arrange the ascending order. Ascending order nothing but, see, the first small values 7, 10, 12, 15, 17, 19 and 25. These are the values which are arranged in the ascending order. The first step is over. Okay. Then in order to find out the Q3 and Q1, Q3 and Q1. So here see, we can go for first Q1. So Q1 is equal, the formula is n by 4. I told you that quarter 1, nothing but total information divided by 4. Nothing but here n by 4, nothing but the numbers or observations in the particular data set divided by 4. I told you the quarter, nothing but how we can find out the quarter. So that is, I told you that whatever the information is given, so we can divide an equal parts. That is, we can divide into the 4 equal parts. 4 equal. That's why I put it at 4. Okay. For example, I told you that if the 10 centimeters table is there, for example, we want to know the what is the quarter of the table. So 10 centimeters divided by 4. 10 by 4. You are going to get 2.5. 2.5 is a 1 quarter. That is called quarter 1. Or else, for example, the number of observations is not even number or odd number. For example, sometimes we need to go for n plus 1 by 4 also. N plus 1 by 4. N plus 1 by 4. So generally in statistical, when we are estimating, we can go for this one, n plus 1 by 4. So generally we can add 1, n plus 1 by 4. What is n here? Nothing but number of observations. So how many number of observations are there? 1, 2, 3, 4, 5, 6, 7. 7 plus 1 by 4. 7 plus 1 is how much? 8. 8 by 4 is equal to how much? When you cancel it, you can get 2. The quarter 1 is 2. Nothing but here 2 is nothing but second item. Second item. Second item. Nothing but second observation. Okay. Then I will show you how we can identify that, how we can select that Q1, Q3. So Q1 is 2. Then we need to find out the Q3 also. What is the Q3? What is the quarter 3? Here 3 into n or 3n divided by 4 or 3 into n plus 1 divided by 4. Here 3 is nothing but quarter 3. N plus 1 by 4. So here as it is, you can take 3. 3 into 7 plus 1. That is the 8. 3 into 8 divided by 4. 3 into 8 how much? 24 divided by 4. So when you cancel it, 4 into 4, 4 6, 26. Okay. 4 6 are 24. So here the quarter 3 is a 6th. Here 6 is nothing but here 6th item in the particular observation. So here the second item is how, what is the second item when you calculate 1 2? 10 is the second item. Sixth item is 1 2 3 4 5 6. 19 is the sixth item. Sixth quote. Here this is the one Q third part. This is the Q1 part. For example, if you divide this data, for example, in that, if you take 10 centimeters, for example, so this is the middle value. Here the 50%. Okay. So here 25%, here 50%, here 75%. It comes under the 100. Okay. Like this, we can select. See here. Here QD is a second formula. Yeah, quartile deviation. Q3 minus Q1 divided by T. Q3 is nothing but how much? Sixth item. Sixth item is nothing but here. I told you that 19. 19. Here. See, QD is equal 19 minus Q1. Q1 is equal how much? 10. The quarter 2. Here 2 is nothing but second item. Select 10 and 19. So 19 minus 10 divided by 2. Your formula is 2. Divided by 2. So here 19 minus 10 how much? You are going to get 9. 9 by 2. So the quartile deviation is equal to 4.5. The quartile deviation is 4.5. That's the answer of the quartile deviation. Then comes to the coefficient of quartile deviation. Coefficient of quartile deviation. So the coefficient of quartile deviation formula is Q3 minus Q1 divided by Q3 plus Q1. Here you can take here coefficient of QD 19 minus 10 divided by 19 plus 10. See 19 minus 10 how much? 9. 19 plus 10 here 29. Sorry, I put it in mistake. Just a minute. 29. 9 divided by 29. The answer will be changed 3.10. See here the coefficient of quartile deviation 19 minus 10 divided by 19 plus 10. 19 minus 10 is 9. 19 plus 10, 29. So when you divide 9 by 29, you are going to get 0.31. So we can say that the quartile deviation is 31%. 31% from quarter to another quarter. Is it clear now? Hello?
Yes, sir. Yes, sir.
Yeah, for example, if you take into account, if the data is in the continuous series, what will happen? How we can calculate? That is a major thing. For example, the question may not ask in that in your examination, but you need to find out the quartile deviation when the data is in the continuous series also. Continue series. For example, they will ask the question, find out the quartile deviation and coefficient of quartile deviation for the following data. Okay, simple, they will give the data of earnings and frequency. Simple, this data only they will give. Okay, you can take consider earnings and frequency. Nothing but, for example, if you take this is a income earned by the particular person in thousands, for example, 10,000 to 20,000. How many members are getting? How many members are earning? 42 people. And 20,000 to 30,000, 25 members are earning. 30,000 to 40,000, 58 persons are earning. So 40 to 50,000, the 42 members are earning. So this is the data is given to find out the quartile deviation, coefficient of quartile deviation. So when the data is in the continuous series, the formula will be changed quietly. See, so before find out the Q3 and Q1, so here we need to find out this formula, lower quartile and upper quartile. Lower quartile is nothing but Q1 and upper quartile is Q3. So whatever we have calculated in the mean and median, simple. So formula is more or less simple, but here there is some difference. Here L plus 1 by 4 or N 1 by 4, N into 1 by 4 minus, here we can say CF or F, capital F, nothing but cumulative proceedings of the cumulative frequency value. Okay. Then small f, this is called frequency. Here frequency of Q1 and into I or C, there is a class interval. Okay. So upper value, upper quartile is same, but whereas Q3 is L, there is the lowest value. Here 3 by N or 3N, sorry, N3 by 4. N3 by 4 or 3 by 4 into N. Something about 3N by 4. 3N by 4 also. No problem. If 3 into N or N into 3, you will get same answer. Minus F divided by small f into IRC. Okay. So then after calculating the Q1 and Q3, we can substitute in the this quartile deviation formula. This Q1, Q3 and Q1. Q3 minus Q1 divided by 2. Okay. So here, first what we have to do when the data is given these two parts only, then first we need to find out the cumulative frequency, because they have asked for the cumulative frequency also. So cumulative frequency is nothing but how we can calculate cumulative frequency. Cumulative frequency is nothing but adding up simple frequencies, Here see 42 as it is, you can put 42. Then 42 plus 25, how much? 67. 67 plus 58, 125. So 125 plus 42, 167. So this kind of thing we can add, nothing but we can add a simple frequencies, simple adding up simple frequencies. The simple frequency is over, clear? How we can calculate a simple frequency? Hello?
Yes, sir.
Yeah. So then we can calculate that Q1 and Q3. Q1 and Q3. See here, in order to find out that Q1 and Q3. So see here, as per formula, Q1 is equal to N by 4 or N plus 1 by 4. See, for example, what is N? Nothing but number of observations. Here, how many people are there in particular our study? How many people are there? Total is 167. When you add this 4, you will get 167, which are close to the, which are equal to the this cumulative frequency. Okay. సో ఇక్కడ మీరు టోటల్ క్యాలిక్యులేట్ చేసిన ఫ్రీక్వెన్సీ 167 రావాలి, ఇక్కడ 167 రావాలి. ఒకవేళ ఇక్కడ 167 రావాలంటే దర్ ఇస్ ఎ మిస్టేక్ when you are calculating the cumulative frequencies. Okay. So 167 plus 1 by 4. So we can go for this formula n plus 1 by 4. We can get value very simple. So when you are calculating the n by 4, you will get values, but the we will get some point values. Okay. So in order to ignore that points only, we can add one n plus 1 by 4. So n is nothing but 167 plus 1 divided by 4. 167 plus 1, 168 divided by 4. When you cancel it, you will get 42. Okay. The quarter one is 42. The quarter one is 42. Nothing but you can select this one. Okay. This class interval. Okay. You can, when you are entering the notes, you can round off this one like this, 42. Okay. Then the quarter third, see 3n plus 1 by 4. 3n nothing but 3 into n. 3 into n nothing but 3 into 167 divided by 1. Yeah, here 3 into 167 plus 1, nothing but 3 into 168 by 4. So here 3 into 168 nothing but 502. 502 by 4, you will get 126. So here we can see that where 126 is lies in the particular cumulative frequencies. ఈ 126 number అనేది ఏ number లో ఉన్నది? Nothing but we can identify where the 126 lies in the particular number. See here, the 126 is lies in the 167. 167. Then you will mark it. So this is the quarter fourth. So when you take into account when you mark it, this is the quarter one and this is the quarter four. Then you can go through this formula, this lower quartile. First L1 1 by 4 CF or capital F by small f into I or C. So I put it here I. Say here, what is the lowest value in the range? Here, see, when you are mark it, the lowest value is 10. So we can take 10 plus n by 4, how much you got it? N by 4, 42. N by 4. So 1 into n is nothing but same, or n by 4 is also same. 1 into 42, 42, or 42 by 4 is also same. So you will get 42 minus CF. CF is nothing but cumulative frequency of the preceding value. Do you have the preceding value of the cumulative frequency? No, we don't have the preceding value of the cumulative frequency. So that's why you can take 0. So దీనికంటే ముందు అనేది ఎక్కడ మనకు వాల్యూ లేదు కాబట్టి so we can take as a 0. 0. Then F, that's the frequency. What is the frequency of this 42? You can take this 42 here. This 42 is this one. This 42 is different. Okay. Small capital F is nothing but cumulative frequencies. Small f is nothing but this frequency. Okay. Here into I nothing but class interval. The difference between the two classes, nothing, how much? 10. That's why I can put 10. So here as it is equal 10 plus 42 minus 0, 42 divided by 42 into 100. So as it is 10 as is equal 10, 42 by 42, 1. 1 by 1, sorry, 1 into 10. So 1 into 10 is nothing but 10. So when you add it 10 plus 10, 20. The quarter one is 20. Quarter one is 20. Then we can find out the quarter third also same. L plus 3n by 4 minus CF by F into I. Same formula. See L. So here L is lowest value of quarter third. What is the lowest value here? 40. We have taken 40. Then 3n by 4. How much we got it? 126. 126. What is the CF? Preceding value of the cumulative frequency. దీనికంటే ముందు ఏదైనా మనకు value 125. That is the preceding value of the cumulative frequency. Nothing but 126 minus 125 divided by small frequency. Nothing but here small f. Small f is here also 42. Here also 42. Don't confuse. Here 42. Here 42. So that the interval is 10. 10. So as it is equal 10 or 40 40 plus 126 minus 125. How much? 1. Divide by 42 into 10. Then 40 40 you can take as it is plus 1 by 42. How much? 0.025. When you cancel it 1 by 42, you are going to get 0.023 into 10. Then as it is you can take 40. Then you can multiply this 0.023 into 10. You are going to get 0.23. 0.23. Then when you add it, the 40 plus 0.23, the quarter, sorry, here quarter third, not 1. Quarter third is equal to 40, 40.23. 40.23. 40.23. So this is a quarter third and quarter 1. Then next we need to apply these values in the quartile deviation. Quartile deviation. See, don't apply this Q3 and Q1, this Q1 value and this Q3 value. Don't apply in this equation. So after getting these values only, you can apply in this, or you can substitute in the equation. Okay, don't confuse. This is the Q1 and this is the Q3. Okay. Nothing but here 3n divided by 1 by 3n plus 1 3n plus 1 by 4 value. So that's why in order to find out this value only we have done this one, this part. Okay, don't confuse. Then see, in order to substitute these values here, Q3 and Q1 value. So in the equation, see the quartile deviation. What is the Q3 value here? 40.23 minus what is the Q1 value here? 20. 40.23 minus 20 divided by 2. Here 2. Then 40.23 minus 20, how much? 20.23 divided by 2. You are going to get answer is 10.115. 10.115. Nothing by the quartile deviation is 10.115. 10.115. This is the answer of quartile deviation. Quartile deviation. Is it clear?
Yes, sir.
Yeah. Then, in order to find out the coefficient of quartile deviation, formula is Q3 minus Q1 divided by Q3 plus Q1. Q3 plus Q1. So you can substitute these values Q3 and Q1. Here 40.23 minus 20, 40.23 plus 20. Okay, Q1 minus Q3 minus Q1, Q3 plus Q1. Then when you substitute, you will get 20.23. When you add it, you will get 60.23. Okay. When you cancel it, 20.23 divided by 60.23, you are going to get 0.29. 0.29. So we can conclude that here uh, in the quartile, the deviation, the coefficient of quartile deviation is 29%. Nothing but an average. We can say that in the quarter, there are 4 quarters in a particular data. So each quarter there is a huge variation. That is, the variation is 29%. We can say that the coefficient of quartile deviation is 29%. Is it clear now? Shall I explain?
It's clear, sir.
Yeah, okay, fine. Then we will go for that mean deviation. For example, see, find out the coefficient of quartile deviation of Q3 is equal to 80 and Q1 is equal to 15. So they have given the data. So this question is asked for that assistant professor entrance exam in Gujarat State in 2019. Okay. See, this kind of questions will ask for that further entrance exams. So if you want to study in Central University, they will conduct examination also. But they will give you the questions from the statistical part also. See, for example, they will ask the question for the net or set and other exams also. They will ask such kind of question. See, find out the coefficient of quartile deviation of Q3 is 80, Q1 is 50. So this question is asked again. I'm repeating that for the entrance of degree lecturers in the Gujarat State for the assistant professor. So they asked the question in 2019. See, they are given answers: A 32.5, 47.5, 68.4, and 1.6, 1.46. So what is the answer? Can anybody can say that? What is the coefficient of quartile deviation? Which option is correct? Hello? Are you doing or are you thinking? Hello?
Yes, sir.
Can you want? Do you want to say or can I do?
Yes, sir.
See here, see the coefficient of quartile deviation formula. They ask for the coefficient of quartile deviation, not quartile deviation. See, okay, coefficient of quartile deviation only QD. Okay, what is the formula of coefficient of quartile deviation? Q3 minus Q1 divided by Q3 plus Q1. Okay, here what is the Q3 value is how much? 80. 80 minus what is the Q1 values? 15 divided by Q3 80 plus 15, right? Then 80 minus 15, how much?
65.
Divided by 80 plus 15, how much?
95.
95 is equal. Then you can cancel
0.684.
68.
5 divided by 95. How much?
0.684.
0.684. So what is the answer in the ABCD? C. So we
C.
can do it in the percentage also. Don't confuse. Here they didn't mention 0.84. So when you are saying in the coefficient values, we can simply say that in the percentage. Okay. The answer is C, or C option is correct. Okay. So here is equal to 68% for, you can say that. Okay, when you convert into the percentage, 68.4%. The C option is the right answer. Okay. So such kind of questions will ask in the further examinations. So please keep in mind that sometimes they will ask the questions about the range also, coefficient of range. Okay. So probably I will also ask the question from this kind of questions in the further internal exams. Okay. So please keep in mind. Okay. Is it understood or shall I explain one more?
It's understood, sir.
Okay. So almost time is left. Only 1.3 seconds. So we may not able to cover mean deviation. Okay, it will take more time for that mean deviation. So that more 2 slides. So tomorrow we will discuss about that mean deviation because the time is not permitted. Okay. Hello.
Okay, sir. Okay, sir.
Okay.
Yes, sir.
So thank you everyone for listening my class, and if you like this video, so I will upload. Please share and subscribe to get more videos with regard to the statistics and econometrics. Okay.
Okay, sir.
Okay. Please go through once. If you're not able to understand, you can ask me questions in the chat box. Okay. Once again, thank you, and please like this video and subscribe and share if it is relevant and if it is good. Okay. Thank you. I'm going to close the session.